Hello my friends, welcome again to my video channel. Today we will start a new project, another Drake TR7 transceiver, shortwave transceiver. It's not my first TR7 and I think it will not be the last one. What is the problem with this transceiver? The RX is okay, but when connecting the power supply to the TX line, I will show you what I mean, then suddenly there's a short circuit and the power supply, the PS7, shuts off with short circuit. So we have to look for the problem. The TR7 has two connections for the 13.9 volt DC line. These are the upper two connectors, plus minus, and these are the lower two connectors, plus minus. These two, the upper twos, are for the PA brick. They are for the heavy currents, and these are for the receive section and also for the complete PLL and also for the transmit path, as long as it is not the power amplifier, but I think all selective circuits, mixers and so on, even for transmit, are supplied by this voltage. And the owner told me when he only connects the DC supply to these two ones, the RX is working, but when he connects the DC, the power supply, to these ones, the upper twos, then the power supply suffers a heavy short circuit. So we will check it and see what happens. For this work, best is to use the appropriate adapter, the plug, which can be inserted here. That's the original one. And here we have two connections. The big ones, the big cable, is for the upper two, which is the power amplifier, and the smaller ones is for the lower two, which is for the supply of the receive path, as we have discussed. So I will first start with these two connections and fire up the transceiver. This is the first check of the receive path. We see 20 meter band is operating. The illumination, the S meter and the scale for the VFO is not working properly. That's not the main problem at the moment. Mode seems to be okay. Calibrator 75, 100, 125, okay. I will choose another band. The contacts are not good. Seems all bands are working, at least with the calibrator. Now I've connected the big cable to a power supply with 30 amps, 12 volt 30 amps, which is good enough for this purpose. And I see we have full power. I use my key. When I increase the output power in mode CW, we have here 100 watt, that's also 100 watt, we have scale 200 watt, full scale, so this is 100 watt. The Vox operates, can reduce the delay. Okay, that's ugly. But no short circuit. Let's go to the 40 meter band. Same procedure. $80 meter. So we go to 21. Also more than 100 watts. And 10 meter 28 could be a little bit less. This is a weak point of the old Drake TR7, but okay, 80 watts only. 60 watt. Here we have 70 watt. This is momentarily not a problem. It works and there is no short circuit. So I have to talk to the owner. We have seen that the transceiver itself is obviously okay, no problems, no shorts inside. So I assume that the problem is the PS7. The owner will bring me the PS7 also, then I can check the whole combo. Meanwhile, while I'm waiting, I replaced the bulbs and the blue foil by new ones, so the optical appearance is now like new, and I can check this transceiver now with the original PS7. The whole combo is installed. The PS7, for those who don't know it, it's a very heavy power source with a big transformer, a lot of transistors. It's a linear regulated supply. Transceiver is connected. And now we'll test it and see what happens when I increase the output power. It's on the 80 meter band. It's set to low power. Okay, that's it. You have seen? I have to wait some minutes. Same problem again. When the transceiver draws power from the power supply, receive is okay. Oh, damage. Receive is okay, but the transmit power obviously is not sufficient from this power supply, and that's a bad sign. Obviously the current limitation or similar generates problems. This again can be repeated, so I have to check the power supply, open it where the problem is. Before we start the search for the fault, a short look into the schematic diagram. We have here a big power transformer. This is a power rectifier. We have 4 transistors in parallel. Each transistor has an emitter resistor of 0.18 ohms, 180 milliohms in parallel. This is the output. Here are 4 resistors for the current sensing, and the voltage stabilizer. It's an 723, the well-known famous voltage regulator in those days. Here are 2 pots for the current setting and for the voltage setting. Maybe we have a problem here with the current setting, that the power supply is triggered and switched off. Here we have the power supply for the regulator. Here is a thyristor which is triggered when obviously the voltage gets too high, as I see. Then this transistor gets conductive, and then there is a voltage fed to this to the gate of the thyristor, and then the voltage or the power supply of the regulator is interrupted. Here we have the crowbar protection, another thyristor, power thyristor, which is triggered by this Zener diode when the output voltage gets too high. It's a protection for the transceiver. If one of the transistors gets conductive, makes a short, then the voltage would be switched through unregulated. This would be deadly for the transceiver. So here we have the crowbar protection. Well, my first assumption is that you have a problem here with the voltage or current stabilization, which causes the limit here to trip or so. Especially the current setting we have seen when only the receiver is operating. It's okay in the moment when the current increases, then obviously there appears some triggering of the overcurrent protection. This would cause or would indicate that you have a problem here in this loop, which is generating the signal for the overcurrent. Okay, let's have a look into the power supply itself. And here we have a look into the beast. It's a very heavy power supply. The transformer itself, you see in relation to my hand, it's a big one. I don't know how many VA it has, but I estimate minimum 300 VA or 350. This type is not, okay, I don't know it. This output And here's a rectifier. These are the filter caps. And here we have the resistors, transistors, sorry, the transistor 2 and 2 another transistors. Here are the emitter resistors, the 4, 1, 2, 3, 4. Here is a voltage stabilizer. Oh, a little bit loose. Okay. This is a voltage stabilizer with the 723 on it. This fuse, I think, is for the second output. There's an auxiliary output, 13 volt output, and some other stuff. Well, I will have a look at it, and it seems that someone was in there. This is a voltage regulation pot for voltage, and this is for the amp. And here I see some note. Someone placed a sticker here for this transistor. Obviously there was someone in before and did a repair or repair attempt, don't know. Let's see. But my first work is to take out this board and to check it whether all components are okay. The board is out, can be removed easily, it can be unplugged. There's a screw. The screw was missing, but it's not a problem because there is no electrical contact. There I have seen some signs of soldering. Looks like someone was in before and replaced, I think, this electrolytic capacitor. Looks new. I will check the transistors, also the capacitors with my ohm meter. The fuse is obviously okay. The fuse holder is corrodized. It's black, but that's not a problem. It's only the output for the auxiliary 12 volt. It has nothing to do with the stabilizer itself. Here we have the 2 pots. Maybe they need cleaning. First I will check the transistors. There are 4 diodes for the rectifier, the electrolytics. I will do it with an ohm meter. So I will start. First I check the fuse, which is not relevant, but just to check it, it's okay. And now I go to, yes, I can leave it in position ohm and volt. Where are the transistors? What am I doing wrong? Volt diode test. Operator 2 stupid error. .68. The other one .68. Well, this transistor looks okay. This one is a thyristor. I have seen the next transistor is with this one. Little PNP. It's a PNP. But looks also good. Here are the 4 diodes. I'm rather sure they are okay. .58, .58, .58, .58. Soldered both capacitors. Check the first one with my capacitance meter. Should have 470 microfarad, it has 395, but the dissipation .47, okay, measuring at 1 kilohertz, but the quality factor only 2, that's not good at 120 hertz. Quality is 13, 14, okay, but I'm surprised why didn't I measure it with the ohm meter. The electrolytic has the same behavior at 1 kilohertz. It is a little bit better. It should also have 470. It has 507 at 1 kilohertz. At 120 hertz. 550. Seems to be an overperformer. We have here, we have R times 10,000. So the center is 10 is 100,000. I connected minus and plus. It creeps up very slowly. kilo ohms, approaching 400 kilo ohms. I will check the other one. But I think this is okay also. Yes, I think they are okay. The capacity. Maybe one of them which has a higher capacity is a little bit an overperformer, but I don't see any problems. I wait some minutes and show you the result. And now we have more than 2 mega ohms. 200 is 2 mega ohms. We are approaching 3 mega ohm. So I think this capacitor is okay. There is no DC leakage. Then let's go to the other one. Well, it is still charged. You see, we stopped the measurement anywhere in this range and it is still charged, so I'm quite sure there's also no leakage problem. And also this capacitor reaches now 2 mega ohm and still climbing upon the hill beyond 2 mega ohm. So I can say both capacitors are okay. The measurement with the digital DC ohm meter was a little bit suspicious. Maybe the mode of measurement is a problem, but you can see here clearly it has no problem, no DC leakage, and capacity is still there. And that there's a difference between 100 Hz and 1 kHz, that's obvious. Such capacitors always have a higher capacity at lower frequencies. So I can still leave them in place. And while I was resoldering the two caps again, I saw that this trace here was repaired. This is a thick wire, it's not the PCB layer, it's a wire, and this goes to the rectifier diodes in the input. These are the diodes. And these diodes are the rectifier diodes for this circuit. And in the AC side, output of the power transformer, there was a damaged wire. Maybe there was a short circuit here, or don't see a short circuit in the electrolytic cap. No, it was, but what we have checked is the cap is okay, but here is stated 100 microfarad. And I've seen we have 470. Maybe the cap was bad, but these diodes also don't look original. Someone made a repair. This is not an original work. A little bit too chaotic. So I'm quite sure there was a short circuit here or here in this area. Okay, I will check now the two pots. Both pots are out. I check them against linearity, but they move smoothly as it should. The scale is non-linear, but that's okay. That's the current setting. Now I go to the voltage setting, the other one. Also okay. I think the pots are okay, no problem. Anyhow, I will clean them a little bit with some drops of cleaner. But in general, this I think is not the problem. two pots are in place again, and I resoldered also some pins. They looked a little bit suspicious, but I don't think that this is a problem. I also checked all the contacts and the counter pins in the power supply. They're all clean, no corrosion, no damage, nothing. So I think this cannot be the problem. There's still one component left to be checked. That's this transistor, this power transistor, which controls the 4 output transistors. And this transistor is not mounted on the board here, it's mounted on the chassis. And I will take it out and check it. It is mounted here, it's this transistor, where someone added a label. Don't know why, but okay. I can take it out, there's a screw. It's better to take it out and to measure it outside. It's difficult to get the clamps on it. I don't try it, I take it out. The transistor is out. It's not the original one. The original one should be a TIP, what is it? TIP31 NPN. But the type installed is a BD241A. Okay, it's a European designation. Maybe someone swapped it. Okay, it was mounted, of course, isolated, as we can see here. I will replace this with a new one, but that's not the problem. I will now check the transistor itself, whether it's okay. Collector to base, base to collector, .62, that's good. And now base to emitter, same. Emitter to collector, nothing. Collector to emitter, nothing. This is of course collector to collector, that's okay. That's also the collector. Yes, but the transistor is okay, NPN, as we can see. And when I reverse the polarity, NPN, nothing. Okay, so I will reinstall this transistor. And then we have to measure again the problem, where the problem is. The power supply is connected again to the transceiver. Full output power, more than 100 watt. Let's try mode LSB. 1, 2, 3. Also okay. I think we'll wait some minutes. And when we have the problem again, I have to check the voltages inside, whether there's an overcurrent trip or so. More than 100 watts, 140 watts. Meanwhile, I drink a beer. Prost. I really don't know what happened. There are two critical points where the output voltage is blocked. The two thyristors. One of the thyristors, which is on this board here, had an electrolytic cap in the gate connection. Maybe this electrolytic cap was not soldered properly. The solder connection was a little bit suspicious. I resoldered it. The capacitor itself is okay. I resoldered it and didn't see a big problem. Lukewarm. PA is also. The transceiver is over-designed. The PA brick is over-designed, The power supply itself is over-designed. It's for 25 or we can say 30 amps. Today when you buy a power supply for 30 amps, 13 volt, it's only a quarter of this volume. Okay, there's a lot of air inside. I really don't know where the problem was. The ALC is acting as it should be. I think I will stop my work today. It's late in the evening and I will continue tomorrow with a new test and see whether anything changed or got worse overnight. And now we are at the end of part 1. In part 2 we will check whether the problem is solved, and I can tell you the problem is not solved. Stay healthy, stay tuned. See you on this channel.